Colby, 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 math.com.
We began our first unit today on data and statistics. We talked about mean, median, mode, and range, and we spent quite a bit of time discussing the idea of finding the mean conceptually by balancing out all the data. Problem number 2 says, over a span of 12 hours, Old Faithful Geyser in Yellowstone National Park erupted 10 times. The length in minutes of the eruptions are shown. So here's our data set. Find the mean length in minutes of the eruptions of Old Faithful listed above. So if we're finding mean, we're finding the average. We can add all of these together and divide by 10. We can consider using that idea of finding the mean conceptually. I see some numbers, 2.8, 4.1. All the numbers are 2, 3, 4, nothing as high as 5. So it's probably going to be somewhere in the 3s would be a reasonable mean. But to pick a mean and then balance all these out with this many data points would be a bit tedious, so that balancing method doesn't lend itself well to this data set. That balancing method, though, will help you on another problem if you keep an eye out for that. We could just add all these together. I'm gonna start stacking them, but I'm asking you not to do that, and I'll tell you why in a second. If you stack all 10 of these addends like this, and then start adding all the tenths together and carry the number and add all these together, yes, you could find the sum that way, but it's much more error prone than simply associating to your advantage. In other words, you can look at this set of 10 numbers and find 2 that go together well and add those 2 together, and then look for another 2 that go together well and add those 2 together. Using the associative property in that way will minimize errors on a problem like that. So why don't you think about a way to set up the expression that way and calculate the mean, or if you're not sure what I mean, go ahead and set it up any way you want, but find the mean and then come back after the pause and see how you did.
Paused.
Here's what I meant by associating to your advantage. This addend, 2.8, goes nicely with this one, 2.2, because 8 tenths and 2 tenths is one whole, and I can add that whole to the 4 I get when I add the 2 and the 2, and so 2.8 plus 2.2 work well together. Similarly, 4 and 5 tenths and 3 and 5 tenths work well together. Um, 4 and 1 tenth goes nicely with 4 and 9 tenths. And I've got 7 tenths, 5 tenths, 6 tenths, and 2 tenths. None of those number of tenths add up to one whole. So I'm just going to go ahead and add 3 and 7 tenths and 4 and 5 tenths. And then the last 2 addends, 2 and 6 tenths and 4 and 2 tenths. I circled them as I went so I wouldn't miss any or I wouldn't use any twice. But it's also good to know that I've got 10 data points and I have 5 pairs of 2 in my expression, so I feel good about not missing any of those. Once we find that sum, we'll divide by 10 to find the mean. We associate it this way because 2 and 2 is 4, 8 tenths and 2 tenths is one whole, and 4 and 1 is 5. So I have 5 plus, this makes 7 plus 1 more is 8. 4 and 4 is 8, plus 1 more is 9. 3 and 4 is 7, and then 7 tenths and 5 tenths is 12 tenths, or 1 and 2 tenths. So I have 7 plus 1 and 2 tenths is 8 and 2 tenths. 2 and 4 is 6, plus 8 tenths, so 6 and 8 tenths. And that will all be divided by 10. Oops. You might notice that this last pair of addends also associate nicely, so that's a nice bonus. 2 tenths and 8 tenths is another whole. 8 and 6 is 14, plus 1 more is 15. So that final term has a sum of 15. And these first 3 terms our 13 plus 9 more is 22. So I have 22 plus 15 over 10, 37 over 10. Hopefully we're not now taking the 37 and dividing by 10, because if we're dividing or multiplying by powers of 10, we can simply shift the digit up to higher or lower place values. 10 is 10 to the first power. So if you think about 37, where the decimal is, if I'm dividing by 10 to the first power, every digit in our base 10 system would move down one place value. And so the 7 wholes would become 7 tenths, the 3 tens would become 3 ones. It has the same effect as moving the decimal one place to the left. So if you're dividing by 10, please don't do this. Just understand that it's 3 and 7 tenths. Minutes. And before I circled it, I should have looked up at my original set of data. If we had found the median, mode, and range, we would have put this data in order from least to greatest. But even without putting it in order, you can tell that the numbers near the middle of the data are going to be in the 3s. And so that gives me a lot of confidence that 3.7 is reasonable for the mean. I hope that helped with problem number 2. Thanks for watching the Homework Help video. I'll see you tomorrow.